Hello my dear students. So hope you have understood the part 1. Let us move on to the second part of your 11th class first chapter in physics, that is units and measurement. So if you have not followed, please go to the comment box and ask me the questions so that I can again prepare those and I can clarify your doubts. Okay? So please don't keep the doubts in your mind, or else it will accumulate pile by pile. So don't ever, never keep the doubts in your mind. So as and how we go on in the further classes, you will understand how hectic the physics portion is. So therefore, each sentence by sentence you have to see in your NCERT book. So I will also go through the NCERT book, right? And I will tell you where, in which part, and what is deleted and what not is deleted, and also what is, even though it is deleted, it is taken in the NEET exam and JEE exam. Okay, they will include in the syllabus. Understood? So we will not neglect any part of the NCERT textbooks. So you have to take the NCERT textbooks and few reference books and some solved books also, that will help you to pass through or understand the physics subject. Okay, so now let us see the common SI prefixes and symbols for multiples and submultiples. So you have already seen for kilo, nano, okay, giga and all. So that is a macro system as well as the micro system. Okay, so macro is what? It is nothing but the higher order. Okay, that is 10 to the power of plus. It will be in plus. So here it is in plus. So micro is what? It will be in the minus. So here it is minus. Right? It will be the small parts, submultiples, and these are the multiples. Right? So here there is a 3 columns: factor, prefix, symbol. Okay. So factor is 10 to the power of 18. We call it as exa. The symbol is E. Then 10 to the power of 15, peta, P. 10 to the power of 12, tera, T, capital T. 10 to the power of 9, giga, G, capital G. 10 to the power of 6, mega, M. 10 to the power of 3, kilo, K, small k. Then 10 to the power of 2, hecto, H. Then 10 raised to 1, deca, da, dm. Now submultiples: 10 to the power of minus 18, etto, A. 10 to the power of minus 15, femto, or we can call it as Fermi also, F. 10 to the power of minus 12, it is minus 12 pico, P. 10 to the power of minus 9 is nano, that you know, N. Then 10 to the power of minus 6, micro, mu. 10 to the power of minus 3, milli, small m. 10 to the power of minus 12, 2, centi, C. Then 10 to the power of minus 1 is deci, that is D. So now let us see the dimensions of physical quantity. So the power to which the fundamental quantities are raised to represent that quantity completely. So now we have 3 fundamental quantities. So totally there are 7 plus 2 fundamental quantities. Okay. So for each we will be taking, like, so for L, that is mass, we will represent it as capital M, length as L, time as capital T. So now these are the dimensions, MLT. These are known as the dimensions. Okay. Then current, electric current, it is A. Then the temperature, Kelvin, capital K, and so on and so forth. Now dimension formula we are going to see here. So acceleration. So acceleration is what? A is equal to V by T. Okay. Now what is V? First we have to deduce that V is what? Velocity, that is a distance by displacement by time taken. So displacement is taken in terms of L, time in terms of T, that is dimensions I am telling. So so V is equal to L T raised to minus 1. So therefore A is equal to what? A is equal to V by T. So L T raised to minus 1 upon T is what? T, capital T. So this T goes up. So it will be A is equal to L T raised to minus 1 into minus 1. So minus 1 is added. So that is L T raised to minus 2. So the dimensional formula A is equal to, that is A is for acceleration. So M place is not there, M is not there. So but we will even then write it as, so A is capital A, that is the acceleration. M is not there, so we will write it as M raised to 0. The dimensional formula. So here you see A is equal to M naught L T raised to minus 2. This is how we are getting the formula. Then density. Density is what? Rho is equal to rho is equal to M by V. Okay. So for mass it is capital M. V is what? L raised to cube. Right? Length into breadth into height. 3 dimensions we will take. So L cube. So it is M, L, this goes up, it will be minus 3. T is not there, but even then we are going to write it as T naught. So this is the formula for equation for the density. Formula for density. Then equation definition, you see, equation obtained by equating the physical quantity with its dimensional formula, that is known as the equation, dimensional equation. Okay. So where it is used, uses of dimensional analysis, how it is used. So there are 3 uses of dimensions. One is conversion of the units from one system to another. Okay. So it may be from centimeter to meter. Okay. And from kg to milligram. So like this it can be converted. I am telling you in the simple forms. So in this way, from one form of a system to another form it will be converted. Next, then to check the dimensional correctness of a given physical relation. Then to derive the relationship between different physical quantities. Say Q equal to f of x. So these 3 I will show you. Okay. So here, that is conversion of units from one form to another form. Okay. So here we are taking the formula for the pressure. We are going to write the dimensional formula for pressure. Pressure is what? Force upon area, force per unit area. So pressure in bracket, square bracket, equal to force in square bracket upon area in the square bracket. Force is what? ML T raised to minus 2. So force is what? It is, first of all, F is equal to MA. So mass is AM. Then A, what we had got? L T raised to minus 2. Okay. So therefore here it is ML T raised to minus 2. Area is length into breadth. So L square. Breadth is also a length dimension and length is already a dimension for length. So L square it will be. So L square we will take up in the numerator. So what happens? This is L raised to plus 1 and here this becomes the L raised to minus 2. So minus 2 plus 1 becomes minus 1. Okay. So m L raised to minus 1 T raised to minus 2 is the pressure dimensional formula. Now Pascal, 1 Pascal equal to 1 kg 1 meter per second and 1 second square per second square. So that is mass is in kg, length is in meter, that is 10 raised to minus 1, then time T raised to minus 2, here it is 1 second raised to minus 2. Okay, in CGS pressure will be, so kilogram will be converted into gram in CGS. CGS is what? Centimeter, gram, second. So here kg is converted into gram, meter is converted into centimeter, and second is the same common. So therefore 1 Pascal by 1 CGS pressure. Pascal is what? It is in the SI unit, and we are going to see in the CGS how many times CGS makes 1 Pascal. Okay, so write 1 kg upon 1 gram, 1 meter by 1 centimeter raised to minus 1, 1 second by 1 second raised to minus 2. So this gets cancelled because it is same. Second, 1 second by 1 second gets cancelled. So what remains here? 1 kg. 1 kg in gram is what? 10 to the power of 3. So 1 we will neglect it. So 10 to the power of 3, and meter in centimeter is what? 10 to the power of 2, that is 100. 100 centimeter make 1 meter, right? Then 1 kg, in 1 kg how many grams? 1000 gram, right? So therefore it is what? 10 to the power of 3, 10 to the power of 2, here it is minus 1. So minus 1 multiplied with 2 will be minus 2. So 3 minus 2 becomes, I am writing the power here, 3 minus 2 becomes 1. So therefore 10 to the power of 1. So 1 Pascal is equal to, so here we will take the denominator CGS into this side. So it comes in the numerator 10 into CGS pressure. 1 Pascal is equal to 10 CGS pressure. So this 1 Pascal is equal to 10 CGS pressure. Understood? So this is how we are going to convert from one form of the system to another form. Right? Then this is how we will do it, and checking the correctness of the system, we will see that one. Now we will see the how to check the correctness of an equation. So all you know that there are three equations of motion. So one is V is equal to U plus AT. This is the first equation. Second is S is equal to UT plus half AT square, and the third one is V square is equal to U square plus 2AS. Okay, understood? So V is equal to U plus AT, S is equal to UT plus half AT square, V square equal to U square plus 2AS. So here S we can write it as X also, right? And okay, so V is what? It is the final velocity, U is the initial velocity, A is the acceleration, T is the time, right? Okay. So now first of all we will take X equal to UT plus half AT square, that is I have written here S is equal to UT plus half AT square, right? So in place of S we will take it as X, right? So what is the dimension for X? It is the length, it is measured in terms of length, so L we will take. Then UT equal to velocity, initial velocity, so velocity into time. So what is velocity into time? Length by time into time. So time and time gets cancelled here. What is remaining? Length is remaining. L, capital L. Right? Then half at square. So half we will not consider because it is a constant value. It is a number. Therefore, we will neglect half. So only take at square. So a is what? Acceleration into time square. So acceleration is velocity by time into time square. So length by time divided by again time into time square. So again here what happens? So time so here it is like time square only, right? So time, it is the length by time is, again here we'll write, so time square it is cancelled out. All the time gets cancelled out. What we are getting? L. So therefore x is also what? Length, that is L. The dimension of x is L. The dimension of ut is also L, and the dimension of at square is also L. So therefore lastly what we have to write here, thus the equation is correct as far as the dimensions are concerned. Or simply, in simple words you can write, hence the equation is correct. Okay, what are you going to write? Hence, when you will prove all this, last one sentence you have to write the, that is the, hence the equation is dimensionally correct. So like this you have to write in the simple sentence. Hence the equation is dimensionally correct. Okay. Yes. So now we will see the conversion of one form to another form. So let us take a simple pendulum, where a simple pendulum is nothing but a simple device where a bob of a mass is attached to a thread, and these two are supported by a stand. So therefore time of oscillations of that bob is proportional to length, mass and acceleration due to gravity. Okay. Now time dimension is what? Capital T. L is what? Again K we will substitute it afterwards. It is experimentally proved value, we will substitute afterwards, and it is a constant value. Okay. A, B, C is what? It is the power. Okay, or the exponents. So L raised to A, M raised to B, and G is what? Acceleration due to gravity. So therefore L T raised to minus 2 raised to C. So L raised to A plus LL is what? Wherever L is there we will add it. So that is L A plus C. So C, if we take inside we multiply, then L raised to C it becomes. So A plus C, L raised to A plus C, then M raised to B, T raised to minus 2C. Okay. Now we will consider only the dimensions, and T is what here? It is again M naught, L naught, T raised to 1 plus 1. Okay. So here we will equate the powers for length, mass and time. So length is what? A plus C. In this LHS, length is raised to 0. So A plus C is equal to 0. Then M raised to B. M is B here, and here M is raised to 0. So B is equal to 0. C is what? Then last one, that for time, T 2C minus 2C is equal to 1. So therefore here C is equal to what we will get? So already we have got for B, that is 0. C is what? C raised to minus 1 by 2. Then substitute in this equation. So what we are going to get? A is equal to half, right? So minus 1 by, so it is like this, A minus 1 by 2 is equal to 0. A is equal to, so minus 1 by 2 goes to the RHS side and it becomes plus, so it will be plus 1 by 2, right? So A equal to 1 upon 2, B is equal to 0 and C is equal to minus 1 by 2. So therefore we will substitute here in the this equation, the above equation, that is t is equal to k l raised to a b m raised to b c raised to g raised to c. So here k as it is outside we will keep. So m is 0 here, that is b is equal to 0, we will not consider. So it is m raised to 0 is 1, right? Then l raised to, so how it becomes, t is equal to k l raised to, what is a value, half, m is 0, so 1 it is, and g is what it is, g raised to c, it is c is what, minus 1 by 2. So therefore 1 by 2 is what it comes in the square root. Okay, therefore we will take the whole square. So as l raised to plus 1 by 2, so it will be in the numerator, and as a g is minus 1 by 2, so it becomes in the denominator, but both are in the square root, so that is L upon G. So this is the final equation for the time period of the oscillations of the simple pendulum. Okay, so these are the extreme points and these are the mean points. So as you go to your college and do the experiment of simple pendulum, you will come to know what is a simple pendulum. Okay, and how the oscillations are. One oscillation is what, if it starts from here, it goes to this way and again it comes back to this position, that is known as one oscillation. So time required for one such oscillation, it depends on this equation. Okay, t equal to k root of L upon G. So hence we get the dimension, and k experiment. So here, from here to here it is 180, that is pi. Again from here to here it is another pi. So the value of k is what it is, t equal to 2 pi under root of L by G. Understood? Value of k is equal to 2 pi. 2 pi how we got? By the oscillations of the one oscillation angle, 2 pi. I hope you have understood till here. So in the next class we will continue this chapter. Please give your feedback, that is very, very important. Subscribe to my channel, like and share to your friends. Thank you.